Okay, in this video, we're going to be talking about evaluating polynomials that have several variables. In other words, we're going to have x's and y's and z's and r's and s's and whatever all mixed together. So we're going to talk about, when we talk about the word evaluating, that means that you're given some value for the variable and you have to put it into the expression and then find out what the answer to that expression would be. So the first thing you want to do is substitute the given value that has to be given, or the number, for each time you see the variable. And whatever was happening to the variable, if the variable was being cubed, you got to do that to the number. If the variable is being squared, you got to do that to the number. So whatever was originally happening to the variable will also happen to the number. Then you just perform the computation. You do it just like you would using the order of operations as we call PEMDAS. Remember that PEMDAS stands for parentheses should be done first. The stuff in the exponents should be done next. Multiplication and division can be done in any order from left to right, okay? And addition and subtraction has to be done last, again, from left to right. So make sure that addition doesn't have to be done before subtraction, or multiplication doesn't have to be done before division. It's really dependent on what's on the left-hand side and what's on the right side. So here we're given this expression, 2x cubed times y plus xy squared plus 7x minus 3, and we want x to be replaced with -2 and y to be replaced with 3. So basically, everywhere there's an x, I put a -2 in parentheses, and everywhere there's a y, I put a 3 in parentheses. And the parentheses are helpful because it keeps track to make sure that whatever I did to the original variable is also being done to the number. So that's really important. So I simply put a -2 in everywhere there was an x, and I put a 3 in everywhere there was a y, and if there wasn't an x or a y, I just kept those numbers. So as you can see, -2 times -2 times -2 is a -8. Here I have 3 times 3, which is 9. I didn't change anything else because I was working with my exponents. Now, if the parentheses are just around one number, that's not the parentheses they're talking about here. Here they're talking about parentheses where there's something to do inside, like 2 plus 3 or 7 minus 4. Those are the parentheses we're talking about. So if it's just a parentheses around one number, you don't really have to worry about doing, quote, that first. So here we have multiplication. So I'm going to multiply from left to right. So this is -16. I'm going to multiply the -2 times the 9 and get -18. Again, I'm going to multiply, and then I just keep this number. So again, I'm going to multiply here. A negative times a positive is a negative. When you add a negative, that's the same as subtracting. Adding a negative is the same as subtracting, and so forth. Now I have a variety of additions, or you can think of adding, negative, or subtracting. So I'm just going to go from left to right. So -48 and 18 is -66. -66 and -14 is -80. And again, you just keep going. All right, so let's try one. So 3 is going to stay 3. X is a -1, and it's cubed. Y is 5. So I'm going to put that in. Everywhere there's an X, I'm going to put a -1. Everywhere there's a Y, I'm going to put a 5. All right, so we just make sure we substitute it in. So now we're going to go ahead and worry about the exponents. A -1 times a -1 times a -1 is the same as -1. All right? And a 5 times a 5 is 25. Okay? So -3 times 5 is -15. And -1 times 25 is -25. We're just going to go from left to right. So this is -40. This is -15. And so you get -9. Excuse me. Okay? All right, so let's talk about adding and subtracting polynomials that have several variables. Again, it kind of goes back to what we learned before. You can only combine the coefficients if the variables and their exponents match exactly. So this has an x to the 1 power, this has an x to the 1 power. This has a y squared, this has a y squared. So since the variables match exactly, you could say I have 7 of the xy squares and 6 more of the xy squares. So I have 13 xy squares exactly, since they match. But here, if you look at this, I have an x squared and a y. This is an x and a y squared. The x's don't match and the y's don't match. So neither one match. So you can't combine them at all. They have to stay the way they are. All right, so let's look at this one. We're going to add this polynomial to this polynomial. Since there's an addition, we don't have to worry about distributing anything. We've got this many xy squares, which is 6. We have 9 more of the xy squares. The x's match, the y's match, and the exponents match. So you can combine the 6 and the 9 to get 15 of those. We've got negative 5 xy's, and we've got positive 2 xy's. The x's match, the y's match, the exponents match, so I can combine the negative 5 and the 2 to get negative 3. The 7 is a constant, the negative 6 is a constant, so we can put those together, and we get 1 as our answer. So let's do an example, okay? So we've got negative 8 x squared y's, and we've got 10 x squared y's. So we can combine the negative 8 and the positive 10 to get 2 x squared y's. We've got negative 3 xy's and positive 5 xy's. The x's are the same, the y's are the same, the exponents are the same. So you can combine, you have negative 3 of them and positive 5, which leave positive 2 of those. Then we look at our constants, a positive 6 and a negative 10. It's the same as saying 6 minus 10. And so the answer is 2x squared y plus 2xy minus 4. All right, let's talk about subtracting polynomials. It's similar. It's like adding negatives. You treat it the same as adding. The difference is you're going to distribute the subtraction out to each affected term and change their sign. For example, this first polynomial is subtracting the second polynomial. So what you need to do is get rid of this negative sign, this minus, by distributing it to each part of what is affected. That means everything afterwards, okay? So this positive 3x cubed gets changed to negative. This negative 6x squared y gets changed to positive. The negative 2xy squared gets changed to positive. And the positive 3 gets changed to negative. This helps us visualize in our mind what's going on. So now I can talk about combining like terms. So a 5x cubed minus a 3x cubed, you can combine those to be 2. Negative 9 x squared y's and 6 x squared y's gives you negative 3. 3 xy squares and 2 xy squares are 5 xy squares. And a negative 4 and a negative 3 give you negative 7. So try this one and then check your answer as we go. I'm just going to recopy the left side because there's nothing changing about it. I'm going to change the sign of each part of the right side because it's affected by the negative. All right, now I can combine my like terms. A 7 minus 4 gives you 3 of these x cubes. Negative 10 and positive 12 gives you 2 of these x squared y's, since they're the same exponents and the same variables. Positive 2xy's and positive 3xy's gives you positive 5xy's. Excuse me, xy squares. And then negative 5 and negative 5 give you negative 10. And that would be your answer. Okay, let's talk about multiplying polynomials that have multiple variables. So you use the same kind of exponent rules that we learned before after multiplying the coefficients. Remember, you can always multiply or divide unlike terms, but when you're adding and subtracting, they have to be the exact same. That's what we did before. So here we're multiplying. So the 7 times the 5 can be multiplied together. The x terms can be multiplied. You have x squared, which remember what x squared means. X squared is x times x cubed, which means you have 3 more of the x's. So altogether, you have 5 x's being multiplied. 1 y multiplied by 2 more y's will give you 3 y's. That's why that works that way. All right, so let's look at this one. We're going to multiply our coefficients. So 6 times 10 is 60. X times x to the 4th means that there's 5 x's being multiplied. 3 y's multiplied together and 2 more y's multiplied together give you 5 y's multiplied together. And that's as simple as you can get because you can't combine x's and y's. Let's do another example. When we're multiplying a monomial times a polynomial, monomial means there's just one part to it, and a polynomial means it's separated by adding or subtracting signs. So first you're going to multiply the coefficients, and then you multiply the variables using the same rules we've just done. So this gets distributed to each part of the polynomial, okay? Just like if it didn't have x's or y's, you would multiply that to each part. So the 3 times the 4 gets pulled together to make a 12. An x squared times an x cubed, they're being multiplied, so you have 5 x's being multiplied. The y times the y squared means you have 3 y's being multiplied in this first term. Now we're going to multiply it by the next term. There's a negative in front of the 6, so 3 times negative 6 is negative 18. X squared is being multiplied. You've got 4 x's being multiplied, 2 y's being multiplied. And then for the last term, 3 times 2 is 6. X squared and y don't have anything to multiply, so we keep them as x squared y. All right, try this, and then stop the video and try it, and then check your answer. All right, so 6 times 10 is 60. X times x to the 4th is x to the 5th. Y squared times y to the 5th is 7y. 6 times negative 2 is negative 12. X times x squared is x cubed. Y squared times y is y cubed. 6 times 3 is 18. And then you have the xy squares. Now you double check and look, there's an x to the 5th, y to the 7th. No more of these have the same x to the 5th and y to the 7th. X cubed, y cubed, this is not matching. You can't combine any of these because the variables and the exponents of those variables don't match. So this would be your final answer. All right, last part of this section, multiplying polynomials in 2 variables. Again, you can use FOIL like we did before. You can distribute or the box method, whatever you want to do. You just need to combine your like terms when you're done. All right, so here we go. We've got x's and y's all mixed together. So in this case, I used FOIL. FOIL meaning the first, so x times 3x, which is 3x squared. Outside, so the x times the negative 5 gives you negative 5x and a y. You can't combine the x's and the y's, so you have to keep them both. The inside is the 4y and the 3x. So the 4 times 3 gives you 12, and the x and the y multiply. We usually write them in alphabetical order. Then the last, 4y and negative 5y give you negative 20, and there's 2 y's, so it's y squared. When you're finished with these, you go back and look, can I combine any of these? Well, yes, there's an x and a y, and there's an x and a y. Same variables, same exponents. So negative 5 and positive 12 give you positive 7. All right, try this in the video, and then come back and see if you got it right. All right, first, outside, inside, last. Combine like terms. And nothing else can be combined because the xy's don't match anything, and the x squares and the y squares don't match anything. Okay, stay tuned for dividing polynomials.